Alright, so we are going to start Unit 8, Day 6. This video is going to talk about something called angles of elevation and depression. And so we're going to talk about what those are. I'm going to give you some definitions, and we're going to do some examples. It should be a little bit shorter video. There's going to be things you need to copy down and write down, so make sure you are doing that, pausing the video if you need to give yourself time to do that, especially with some of the word problems we're going to be working on. You'll want to copy those down. Alright? But first we're going to talk about what angles of elevation are and what angles of depression are. Okay, and so when we have an angle of elevation, we're talking about, and these are my attempts at an eye, okay, when we look at a point above that horizontal line from our eye, okay, when we look up to a point above, we're forming an angle of elevation. And then when we look down from that horizontal, we get an angle of depression. So we're going to talk about what those are, and I'll give you some more in-depth definitions of those right now. Okay, an angle of elevation is formed by looking up, and it's the angle formed by a horizontal line and the line of sight to a point above that horizontal line. Okay, and so you'll notice that line of sight always represents the hypotenuse. The horizontal is one leg, and then that point directly above its spot on the horizontal creates this vertical line, which is our other leg. Okay, so anytime you look above that horizontal line of sight, you're forming an angle of elevation. And an angle of depression is formed when we are looking down. So if we take our horizontal and we look down to a point below that horizontal line, we get an angle of depression. So it's the angle formed by a horizontal line and the line of sight to a point below. Okay, so angles of elevation looking up, angle of depression looking down. Okay, and in a lot of the situations we have, you will have both an angle of elevation from one point of view and an angle of depression from another point of view. So I'm going to give you an example that illustrates that. And again, these drawings that I'm doing, as long as you focus on drawing a right triangle, do your best. Maybe you can draw a better eye than I can. But in these next drawings, don't focus on any artistic ability, especially mine, but just try your best to copy it down how it looks on my paper. Alright, so here's what I've drawn here for you. Pretend it's a building, okay? So we've got some building where, pretend there's a person at the top of that building looking out at the horizon this way, but then along the ground level out here, there's another person looking up, okay? And so if I have this person looking down at the person below, okay, we'll call that person A, this person B. When person A looks down at person B, he forms an angle of depression. So angle 2 is an angle, I'm going to use my angle symbol, of depression. Okay? But when I have person 1 at ground level looking up at person B, angle 1. Person B looking up at person A, he forms an angle of elevation at angle 1. So we can say angle 1 is an angle of elevation. Alright, and so those are the different angles. But what you would notice in this case, because this horizontal line is parallel to the ground, angle 1 and angle 2 end up being congruent to each other. Okay, because they're alternate interior angles. And so they're different directions, one's depression, one's elevation, but they're congruent angles. They have the same measure. So let's keep going and let's actually work on some examples that use angle of elevation and angle of depression. Alright, here's our first example. Casey sights the top of an 84-foot lighthouse at an angle of elevation of 58 degrees. If Casey is 6 feet tall, how far is he standing from the base of the lighthouse? So we need to draw a picture of this to identify what kind of angle we're using and how we can use trigonometry to solve that problem. And so we're going to notice it's an angle of elevation. So we're going to draw our lighthouse as our vertical line. Okay, remember the lighthouse is 84 feet tall. All right, there's the top of the lighthouse. Okay, you don't have to actually draw a lighthouse, you just have to Draw a vertical line. All right? And then Casey is somewhere out here along the ground. Okay? And he's standing, and it does tell you he's 6 feet tall, which is an important piece of information because his line of sight isn't from the ground. Okay? He's not laying down on the ground looking up. He is standing up. Okay? And he is 6 feet tall. And so his line of sight goes from his eye to that top of the lighthouse. But the horizontal we are going to use is this horizontal line. Okay? We're assuming that Casey's standing on the same level ground as the base of the lighthouse. And so this that we want to use, we're not going to use the full 84 feet. Okay? And I'm going to show you what we are going to use right here. Okay? We are only using this triangle. Remember I said we had to use trigonometry to be able to do this. So we actually don't even want to consider that part of the lighthouse. We're only going to go up 6 feet. So if the lighthouse is 84 feet tall, this side of the triangle that we're going to use, we're going to do 84 minus 6. If we do 84 minus 6, we get 78 feet. All right? And so let's take a look at the rest of the information. It tells us the angle of elevation, that would be this angle from his horizontal line to his line of sight. That angle is 58 degrees. And we know this leg of that triangle now, and it asks how far he is standing from the base of the lighthouse. So we're looking for this measurement. Okay? And so what we need to do is set up something using trigonometry. And so we're going to identify SOHCAHTOA to help us out. If this is our reference angle, the angle of elevation is going to be a reference angle. The 78 feet, that leg of the triangle, is the opposite leg. And we are looking for this other leg, which is the adjacent leg. Since I'm using O and A, I want to set up my tangent ratio. So I'm going to set up tangent of 58 degrees is equal to the opposite leg, in this case 78, over the adjacent leg, which I don't know. So we can call that x. And so that's what we're looking for. And remember, to solve this, we're going to set it up as a proportion so that we can cross multiply. 1 times 78 is 78. And then x times the tangent of 58, we write exactly like we said it. So that to get x by itself, we're going to divide both sides by the tangent of 58. Make sure you're remembering back to those previous lessons when we talked about trigonometry. So when I put that part in the calculator, that's what gives me my answer. Okay, when we enter that in the calculator, we get that x is 78.7 feet. All right? If you have any more questions about that, maybe you put it in your calculator and you got something different, then go ahead and bring it to class and ask about it. But we're going to continue on to one more example. All right, in this example, we have a dog that is standing 5 feet from the base of a tree, looking up at a cat that has climbed 16 feet up the tree. What is the angle of elevation from the point where the dog is standing on the ground to the cat? Now pause the video if you need to copy this down, but then I'm going to have you draw the following picture to go along with this. We know that the dog is 5 feet away from the base of the tree. The tree forms a right angle with the ground, and the cat is 16 feet up the tree. And it asks, what is the angle of elevation? Okay, so that's what we're going to call x. And so now we get to set up an inverse trig equation to help us solve this. All right? And so we have a right triangle. The two sides that are given form the legs. This is our angle of elevation. Notice it says from where the dog is standing on the ground, so we don't have to worry about the dog's height or anything like that. We're just going from a place on the ground. We want to find that angle. All right? In order to do that, we are going to use SOHCAHTOA again. The 16 feet up the tree is the opposite leg to that angle, and the 5 feet on the ground is the adjacent leg, so we're again using tangent. So we can say the tangent ratio of x equals the opposite leg over the adjacent leg. So that means we need to take the inverse tangent of that ratio to find out what x is in degrees. And so that's the part we put in the calculator. I'll remind you how to do that. Okay, we're going to make sure we're set in degrees, but then we're going to do the inverse tangent of 16 divided by 5. And we find out that that is a 73-degree angle almost. Since we're finding an angle measure, we do want to round up to the nearest degree or down to the nearest degree, but in this case, it's about 73 degrees. All right, and that's the only examples I'm going to cover in the video. We'll do some more examples in class using angles of elevation and angles of depression. With any of these pictures we draw, you do not have to make them extremely detailed. All you need is the triangle that needs to be used, okay? So we're going to do some more examples, but most of the time you'll notice we end up using the tangent function to find these angles of elevation and angles of depression.